Casual flying in Microsoft Flight Simulator often feels chaotic and messy. For example, on takeoff and climb-out, you're trying to hold the extended center line while also climbing at VY, your best rate of climb airspeed. And it's never quite perfect. Now watch this. Runway heading is locked and the airplane climbs at a constant airspeed all the way to the selected altitude. No chasing pitch, no drifting, just a smooth and stable climb. There's an easy technique using the G1000 Autopilot to accomplish this. Heading mode keeps you aligned with the runway, and flight level change holds VY all the way through the climb. Here in the Cessna 172, we're on a 300-degree heading, climbing at 74 knots up to 1,500 feet. Notice how stable this is, with a constant speed and steady heading, and I can do it largely hands-off. In this video, I'll show you exactly how to use the G1000 Autopilot in VFR across 5 practical phases of flight. We'll take a tour in the Cessna 172 around the Golden Gate Bridge in downtown San Francisco, where these techniques really start to come in handy. Climbout is one of the highest workload parts of the flight, so here's how to make it easier. In our flight today, we're starting at Half Moon Bay Airport on the Pacific Coast near San Francisco, which is basically at sea level. We'll be taking off from runway 30, which is a 304-degree heading pointing generally northwest. First, we'll use the heading knob to set the heading we want the autopilot to hold when we engage it. The HDG knob is on the left side of the MFD, the multifunction display, to the right of the PFD, which is the primary flight display. You can see what happens if you rotate the heading knob. If you have a G1000 replica physical panel, now's the time to use the knobs and buttons on it rather than the mouse. I've set the zoom level of the MFD so you can see the airport and runway that we're taking off from in more detail. The dashed heading line changes direction on the MFD. Now press the HDG knob itself or right-click it. This aligns the cyan heading bug to the current heading, as you can see on the PFD. Now rotate the altitude select knob to set your desired level off altitude. For us today, that altitude will be 1,500 feet. Use the outer knob for thousands of feet and the inner knob for hundreds of feet. You can rotate the knob by pressing and holding the mouse and moving it left or right, or by using the mouse wheel when the knob is active. Press the heading button, not the knob. You'll see the annunciator panel at the top of the PFD, also called the scoreboard, change to show HDG and PIT in green and ALTS in white. This means heading and pitch are being held and altitude is being selected. Notice that the box in the middle between HDG and PIT is empty. This means that we're in flight director mode and the autopilot has not yet been engaged. When it's engaged, you'll see AP here for autopilot. As it stands now, if we were to take off and engage the autopilot by pressing the AP button, it would hold our 304-degree heading, but it would also maintain the pitch the aircraft had when we engaged it. This isn't exactly what we want. It's easier to dial in the speed you want rather than the pitch that would achieve that speed. To do that, press FLC for flight level change. You'll see PIT change to FLC and it will show 0 knots. Now use the nose up button to increase the target airspeed. For the Cessna 172, VY is 74 knots, so that's what we'll set. The white ALTS indicates altitude capture is armed, not yet holding. Let's release the parking brake, advance the throttle, and start the takeoff roll. We haven't yet engaged the autopilot, so we hand fly until the aircraft is stable and close to the target airspeed, pitch, and heading. Once we have a positive rate of climb and are near 74 knots, press the AP or autopilot button. The autopilot is now engaged, as shown by the AP indicator on the annunciator panel. The aircraft may wander slightly at first as it captures the selected heading and airspeed, but after a few seconds you can see on the PFD and MFD that we're in a stable climb tracking the extended centerline. We'll be doing a straight-out departure out of Half Moon Bay and then turning right to hug the coastline as we fly north towards the Golden Gate Bridge. I've flown this exact route as a student pilot in the Cessna 172, and it's one of the most scenic and beautiful flights you can imagine. But it's also extremely challenging. Here, you're very close to SFO, the main San Francisco airport, which has a lot of heavy jet traffic. In fact, we are right under the Bravo airspace, which has complicated cutouts or shelves. That's what these cyan lines are on the MFD. For one of the small shelves we'll be flying under, the floor of the Bravo is 1,600 feet. You can't enter that airspace above 1,600 feet without clearance from air traffic control. If you're hand flying without the autopilot, it's really easy to overshoot your desired level-off altitude or drift upward a couple hundred feet, which could put you in the Bravo. So it's really good practice here to use the autopilot to help you maintain the proper altitude. And fun fact, in this mode, if you look on the MFD, you'll see a little cyan arc in front of the aircraft. This is the point on the map where the system estimates you'll reach your preset altitude. As you approach the 1,500-foot altitude that you've selected, you'll see the system annunciator show ALTS in green, which means it's armed to capture the selected altitude. As it levels off, that changes to ALT in green. That means it's now holding the 1,500-foot altitude. And we still are holding the 300-degree heading that we previously set. One important thing to note is that autopilot is not controlling the throttle, so the way it controlled the airspeed in the climb was by adjusting pitch. We still had to set full power on the throttle. In cruise, in a real aircraft, you typically want to keep the RPM at the top of the green arc or less to avoid excessive engine wear. So after we level off, we need to bring the throttle back a bit. Notice that as we do that, the airplane pitches up and down a bit while it settles back to the chosen altitude. This is perfectly normal, but generally it's a good idea to move the throttle smoothly to make this oscillation as gentle as possible. If you were to throttle back without the autopilot, you would likely see an altitude change, and you would have to correct it by changing pressure on the yoke to adjust pitch. With the autopilot, the altitude is held for you. It does that by automatically adjusting pitch. We're going to use the heading knob to get us over to the coastline. With the autopilot on, you can simply rotate the heading knob and the aircraft will start flying that new heading. As before, you can press and hold the knob and move the mouse left and right, or use the mouse scroll wheel to adjust it. We'll approach the coast, making heading changes using just the heading knob and not touching the yoke at all. As we approach the Golden Gate Bridge, this is where it really starts to get fun. The Golden Gate Bridge towers are about 750 feet high, so at 1,500 feet we'll be about 750 feet above them, which is a perfect sightseeing altitude. We can orbit or circle the bridge by repeatedly turning the heading knob without worrying about gaining or losing altitude, and while still being able to look outside. Again, in this area there are nearby hills and often multiple aircraft circling, so it's really important to keep your eyes outside the cockpit. Here are a couple of photos of what this looks like from a real-world flight I flew as a student pilot a few years ago. The sim does a pretty good job of recreating the experience visually. After circling the Golden Gate Bridge, we're going to climb a bit higher to get a better view of the tall buildings in downtown San Francisco. We'll change our heading to point toward downtown. We want to climb a bit, but this time we'll do it in a slightly different way. We'll use vertical speed, or VS mode. In this mode, we choose the climb rate in feet per minute rather than targeting a specific airspeed. This is useful because you typically want a fairly gentle climb or descent rate for passengers, usually in the range of about 400 to 600 feet per minute. First, we'll set our desired altitude to 2,200 feet. Then we'll press VS to enter vertical speed mode. The annunciator changes to VS with 0 feet per minute. Now press the nose up button several times to select 500 feet per minute. The airplane starts climbing at 500 feet per minute as selected. But notice that we're not at full power, so the airspeed starts to drop. Normally you'd want to be at least at the top of the green arc, but I just wanted to show what happens here. If you have too little power, your airspeed can drop significantly below the 74 knots we saw earlier, and you could stall, so don't do that. As you can see, the new scenery in Microsoft Flight Simulator 2024 for San Francisco is really quite good. And as a side note, while I've stayed clear of the Bravo airspace here, I've actually busted the Class Charlie airspace of Oakland across the bay. If you wanted to fly directly over downtown San Francisco, you would need to stay below 1,500 feet. Now we're heading back to Half Moon Bay Airport, and I'm going to show you one more great use of the G1000 Autopilot. But this one is a little more involved to set up. We're going to land on runway 12, the opposite direction from where we took off. I've set the wind to calm today in the sim, so this isn't a big deal. As we turn south along the coast, it can be a little difficult to spot where Half Moon Bay Airport is, but we can use the G1000 GPS to help us navigate toward it. We're still in heading mode with altitude hold at 2,200 feet. I can press the soft key under nearest on the PFD to bring up a list of nearby airports. I'll select KHAF by rotating the FMS knob. I'll then press Direct To button. It looks like a D with an arrow through it. Then press ENT or Enter to activate it. Now make sure you're in GPS navigation mode by pressing NAV or NAV. A couple of things to check here. The HSI, the compass-like display on the PFD, should be magenta and say GPS ENR, or GPS en route. If it's green or another color, or you're not in GPS mode, this won't work as expected. You'll see the annunciator now shows GPS mode. On the PFD and MFD, you'll see a straight magenta line from your current position to Half Moon Bay. You'll also see KAHF in magenta with distance and bearing. On the newer G1000 NXI, you may also see a series of magenta boxes showing the path to follow. With the autopilot on, the aircraft will follow them automatically, or you can turn the autopilot off and hand fly using the flight director for guidance. There's a problem here, though. This path to Half Moon Bay takes you over a hill just before the airport, so it's not easy to make a smooth descent. It's also generally preferred to stay slightly offshore here for traffic separation and to remain clear of the Bravo. You could do the mental math and plan your descent manually, but there's a much better way, and it works at almost any airport even without a published instrument approach. We'll go to the MFD and press FPL to bring up the flight plan created by the Direct 2. Then press PROC or Procedure and select Approach, and then press Enter. You'll see the published IFR approaches for Half Moon Bay, but you'll also see a Visual 1.2 and Visual 3.0 approach. Visual approaches like these are available even at airports without instrument procedures. That means this works even at smaller or backcountry airports, even without VASI or PAPI guidance. It's also simpler than flying a full instrument approach. We'll select the straight-in transition rather than vectors. Scroll down and press Activate. You'll see a note that obstacle clearance is not provided. That's important. Unlike ILS approaches, these visual approaches are computed automatically, so you still need to ensure terrain clearance. On the MFD, you'll now see a path extending from the runway center line and a generated fix called straight, or STR-GHT. The idea is to fly to straight at the computed altitude, which is about 1,661 feet, and then turn inbound. From there, you're on a 3-degree glide path to the runway. Once activated, the aircraft will start following the magenta path, but we still need to descend. We'll set 1,600 feet as our target altitude, close to the altitude at straight. Then press VNAV or VNV to enter vertical navigation mode. You'll see VPATH or VPTH appear in white on the annunciator, meaning it's armed but not active. The system calculates a top of descent point along the path. You'll see straight as the active leg and the time to TOD or top of descent counting down. As we reach the top of descent, VPATH turns green and the aircraft begins descending at about 500 to 600 feet per minute. Now press APR to arm the approach. GP will appear in white, indicating glide path is armed. After reaching straight, the system will capture the glide path. The annunciator will show GPS AP GP, meaning we are tracking glide path, but the autopilot isn't controlling speed. So we reduce power to about 1,700 to 1,800 RPM and add the first notch of flaps below 85 knots. As we slow further, we add more flaps and target about 65 knots on short final. The aircraft stays on glide path and runway heading. We manage airspeed with pitch and power as needed. The G1000 doesn't support full auto land. At about 300 to 400 feet above ground, we disengage the autopilot and hand fly the landing. At this point, the aircraft is stable and well aligned. Make small corrections, pitch for airspeed, and adjust power to keep the aiming points steady in the windshield. You may see PAPI lights showing one white and one red, indicating you're on glide path, but this is hard to see at this airport. Having this stabilized setup makes the approach much easier. Let's quickly summarize the 5 practical ways we use the G1000 Autopilot in this flight. Stable climb out with heading and flight level change, altitude control with altitude hold, hands-free sightseeing using heading changes, precise climbs with VS mode, and stabilized approaches using VNAV and the visual approach. These aren't edge cases. These are practical everyday techniques you can use on almost any VFR flight. And they aren't cheating in the sim. These are real-world techniques that transfer to actual flight training. In fact, the Cirrus training curriculum actively recommends using automation when appropriate to ease pilot workload. The sim is the perfect place to practice those G1000 procedures. You don't need a flight plan, and you don't need to be flying in IFR. The real goal here is reducing workload. Let the autopilot handle precision, so you can focus on looking outside, navigating, and just having more fun. And if you still want to hand fly, you can use all of this in flight director mode. You still fly the airplane yourself, but the PFD and MFD will guide you through visual cues showing you exactly where to go. And one added benefit, using the autopilot helps you learn what precise flying actually looks like. You start to recognize the sight picture, the pitch, the stability, especially on approach and landing. And that makes you a better pilot even when the autopilot is off. If you found any of this useful, please consider liking and subscribing. It really helps my channel grow. Thanks for watching, and happy simming.